Gravitational energy is potential energy associated with the gravitational field. This phrase is found frequently in scientific writings about quasars and other active galaxies. Quasars generate and emit their energy from a very small region. The emission of large amounts of power from a small region requires a power source far more efficient than the nuclear fusion that powers stars. The release of gravitational energy by matter falling towards a massive black hole is the only process known that can produce such high power, continuously. Stellar explosions, supernovas and gamma-ray bursts can do so, but only for a few weeks. Newtonian mechanics. According to classical mechanics, between two or more masses a gravitational potential energy exists. Conservation of energy requires that this gravitational field energy is always negative, particularly between any two-point masses, and there always exists a gravitational force of where r is the distance between their centers. Increasing the distance from to reduces the force, but, since forces in Newton mechanics indicate how much potential energy is lost over space, this separation requires of energy. Performing positive work equal to E units of energy, we can recede objects from R0 to R1 special units apart. By performing positive work equal to, the second term vanishes and objects are infinitely separated. Because gravitational force stops pulling objects together at that distance, is known as gravitational binding energy, which is infinite since the gravitational force is infinite there. General relativity. In general relativity, gravitational energy is extremely complex, and there is no single agreed-upon definition of the concept. It is sometimes modeled via the Landau-Lifshitz pseudo-tensor, which allows for the energy-momentum conservation laws of classical mechanics to be retained. Addition of the matter-stress energy-momentum tensor to the Landau-Lifshitz pseudo-tensor results in a combined matter plus gravitational energy pseudo-tensor which has a vanishing 4 divergence in all frames. The vanishing divergence ensures the conservation law. Some people object to this derivation on the grounds that pseudo-tensors are inappropriate in general relativity. But the divergence of the combined matter plus gravitational energy pseudo-tensor is a tensor.